Hello everyone, welcome back to the channel. Today we are going to explore a question that surprises many people when they look at modern air forces, especially in 2026. And that is why Israel continues to modernize its fighter jets without fully replacing their engines. At first glance, this may seem counterintuitive. Engines are often seen as the heart of an aircraft, the source of its speed, power, and performance. Yet Israel has consistently chosen a different path. To understand this decision, we need to look at how modern air combat has changed. Air superiority today is no longer decided purely by raw speed or engine thrust. Modern fighter jets are platforms for sensors, data processing, networking, and precision weapons. The engine matters, but it is no longer the defining factor in most combat scenarios. Israel's Air Force has long focused on real combat experience rather than theoretical performance. Every upgrade decision is based on lessons learned from actual operations. In real missions, pilots rely more on situational awareness than on top speed. Knowing where the enemy is before the enemy knows where you are is often more important than flying faster. This is where avionics, radar systems, electronic warfare, and data fusion become critical. These systems can be upgraded without changing the engine. Israel has invested heavily in advanced radar technologies. Modern radars allow fighter jets to detect, track, and engage targets at long distances. An upgraded radar can completely change how an aircraft fights, even if the engine remains the same. Detection range often determines who fires first. Electronic warfare systems are another major focus. These systems allow aircraft to jam enemy radars, deceive missiles, and remain hidden. Improving electronic warfare capability can dramatically increase survivability, sometimes more than adding extra engine power. In 2026, air combat is increasingly about information dominance. Fighter jets act as flying command centers rather than just interceptors. Israel upgrades mission computers, data links, and software to ensure its aircraft can process vast amounts of information in real time. Replacing an engine does not improve this digital advantage. Upgrading onboard systems does. Another key factor is reliability. Fighter jet engines are among the most complex machines ever built. Israel operates in a region where aircraft must be ready to launch on very short notice. Reliability and maintenance speed are critical. Existing engines in Israeli fighter jets are well understood by maintenance crews. They have decades of experience servicing them. Introducing a new engine would require massive retraining, new spare parts, and changes to maintenance infrastructure. This transition period could reduce readiness, which is unacceptable for a country that relies heavily on rapid response. Cost is another important consideration. Developing or integrating a new engine is extremely expensive. Engine replacement often requires structural modifications to the aircraft. This can introduce new risks and delays. Israel prefers to spend its defense budget on upgrades that provide the greatest operational return. Upgrading sensors, weapons, and software often delivers far more capability per dollar than replacing engines. There is also the issue of export restrictions and supply chains. Advanced jet engines are tightly controlled technologies. Relying on foreign suppliers for new engines can introduce political and logistical risks. Israel values strategic independence. By retaining existing engines, it reduces dependency on external approvals. At the same time, Israel does not ignore engine performance entirely. Instead of replacing engines, it focuses on incremental improvements. Engine software updates, improved maintenance techniques, and minor hardware enhancements can improve performance and efficiency. These improvements can extend engine life and maintain competitiveness, without the risks of full replacement. Another major reason is mission profile. Israeli fighter jets rarely need extreme long-range or sustained high-speed flight. Most missions are conducted relatively close to home territory, with strong support from ground-based systems. This reduces the need for more powerful engines, designed for long-range or supercruise performance. What matters more is acceleration, reliability, and responsiveness, which existing engines already provide. Weapons modernization plays a crucial role in this strategy. Modern air-to-air missiles can engage targets far beyond visual range. The effectiveness of these missiles depends more on targeting data than on the launching aircraft's speed. By upgrading sensors and networking, Israeli jets can fully exploit advanced weapons without changing engines. Air-to-ground missions also benefit more from precision guidance and real-time intelligence than from engine upgrades. Smart munitions allow aircraft to strike accurately from safe distances, reducing exposure to enemy defenses. Israel places heavy emphasis on software-defined capabilities. Many modern upgrades are software-based rather than hardware-based. This allows rapid adaptation to new threats without physically modifying the aircraft. Engines, by contrast, are hardware-intensive and difficult to modify quickly. Software upgrades can be deployed faster and updated continuously as threats evolve. Another factor is aircraft balance and aerodynamics. Changing an engine can affect weight distribution and flight characteristics. This would require extensive testing and certification, even for experienced air forces. Israel prefers proven platforms that pilots already know intimately. Familiarity reduces training time and improves combat effectiveness under stress. Pilot skill remains a decisive factor in air combat. Israel invests heavily in training and experience. A highly trained pilot with excellent situational awareness can outperform a faster aircraft flown by a less experienced pilot. Upgrading cockpit displays and controls enhances pilot performance far more than a modest engine upgrade. Modern cockpits provide intuitive interfaces, helmet-mounted displays, and augmented reality overlays. These systems allow pilots to focus on decision-making rather than basic aircraft management. Israel has been a pioneer in integrating such technologies into its aircraft. Another reason engines are not replaced is platform lifespan. Many Israeli fighter jets are expected to remain in service for decades. Rather than replacing them entirely, Israel upgrades them incrementally to remain relevant. This approach spreads costs over time and avoids sudden capability gaps. It also allows the Air Force to adapt gradually as new technologies mature. In 2026, engine technology is advancing, but not at the same pace as electronics and software. The performance gains from new engines are often incremental rather than revolutionary. By contrast, improvements in sensors and networking can completely transform combat capability. Israel chooses to focus where progress is fastest and most impactful. There is also a strategic doctrine element. Israel's defense strategy emphasizes deterrence and rapid dominance. The goal is to overwhelm adversaries early in a conflict through superior intelligence and precision. Engines play a role, but they are not the primary enabler of this strategy. Integration with other assets is crucial. Israeli fighter jets operate as part of a larger network. They share data with ground radars, air defense systems, drones, and command centers. This network-centric approach multiplies effectiveness without changing engines. A faster engine does not improve data sharing. Better communication systems do. Israel has also gained deep experience modifying aircraft beyond original manufacturer designs. This allows unique upgrades tailored to specific regional threats. Engine replacement would often require manufacturer approval and cooperation. By focusing on internal systems, Israel maintains greater control over upgrades. In some cases, engine replacement could even reduce stealth or increase detectability. New engines may have different heat signatures or radar profiles. Maintaining known signatures allows better integration with existing countermeasures. Fuel efficiency is another consideration. Modern missions prioritize loiter time and endurance. Existing engines, combined with efficient mission planning, often meet these requirements. Upgraded avionics can optimize fuel use more effectively than engine replacement alone. Israel also prepares for a wide range of conflict intensities. From high-end air combat to low-intensity precision strikes, flexibility is key. Engine upgrades often optimize for specific performance envelopes. System upgrades improve versatility across all mission types. Training infrastructure also plays a role. Simulators and training programs are tailored to existing aircraft configurations. Changing engines would require updating training systems at significant cost. Israel prefers continuity that allows pilots to transition smoothly between aircraft variants. Another important factor is risk management. Engine integration carries technical risks. Unexpected issues could ground aircraft during critical periods. Israel minimizes such risks by upgrading proven components. Combat readiness is prioritized over theoretical performance gains. Historical experience reinforces this approach. Israeli air operations have repeatedly shown the value of intelligence and precision. Successful missions often depended on knowing enemy defenses and exploiting weaknesses. Engines alone do not provide this advantage. In 2026, threats are increasingly asymmetric and technologically complex. Adversaries use surface-to-air missiles, electronic warfare, and drones. Survivability depends on detection, evasion, and countermeasures. These are system-level capabilities, not engine-dependent ones. Israel also benefits from close cooperation between its military and defense industry. This allows rapid development and integration of upgrades. Engine replacement would slow this cycle due to certification and testing requirements. By keeping engines constant, upgrades can be fielded faster. Another subtle reason is logistics during conflict. Spare engines are bulky and difficult to transport. Maintaining existing engine inventories simplifies logistics under pressure. This is crucial in sustained or multi-front conflicts. Israel designs its air force to function even under supply disruptions. Keeping known engines reduces vulnerability to shortages. International comparison also matters. Many leading air forces follow similar upgrade paths. They modernize avionics and weapons while retaining engines. This reflects a broader understanding of modern air combat priorities. Israel simply applies this logic with greater urgency due to its security environment. In summary, the decision not to replace fighter jet engines in 2026 is not about cutting corners. It is a deliberate strategy focused on real-world effectiveness. Israel prioritizes awareness, precision, reliability, and adaptability. Engines remain important, but they are no longer the centerpiece of air superiority. By modernizing everything around the engine, Israel ensures its fighter jets remain lethal and relevant. This approach allows rapid response to emerging threats. It maximizes combat readiness while controlling costs and risks. Most importantly, it reflects a deep understanding of how wars are actually fought. In the skies of 2026, victory belongs not to the fastest jet, but to the smartest one. And that is why Israel modernizes its fighter jets without replacing their engines.